This tutorial will show some of the nuances of using the Align Vertical Horizontal command, a powerful command that allows you to align points to either grid lines or to other points. What this command moves and aligns is points. If you select an area object, it will align the corner points. If you select a line object, it will align the end points. For the easiest control over the alignment process, it is best to align to a grid line or create a temporary grid line where the point is to move, and we will show you why shortly. We will also show why it is best to use this command in a local sense rather than on a global scale, and to test it out on a small model first before applying it to a large model. What you are looking at is the hierarchy that the program uses to align or move points. It checks for these various conditions in both the vertical and horizontal directions. Taking a look at the vertical move diagram as a representative sample, the program first checks to see if it can move to a horizontal grid line. If not, it will check the next condition, which is a horizontal line through a column support, followed by a horizontal line through an unselected point, followed by a horizontal line through a selected point. If none of these lines fall within the specified tolerance for the vertical move, the point is not moved. Please note that once a point is moved in a specific direction, it will not be moved again in the same direction for any of the conditions that may follow. It is important to also note that when checking against lines through points, it checks the points in the order drawn. From this flowchart, you can see that this command has many conditions to check, which in turn are very order dependent, and thus it is important that you understand this option before using it in any substantial manner. Now let's see how this works in reality. We start with an area object where we want to move the top right corner to the top horizontal grid. Select the point to be moved and go to the Edit, Align Vertical Horizontal command. In the Edit box, enter a value of 14 inches. Note how the joint moved up to the horizontal grid line, but did not move to the vertical grid because this distance exceeds 14 inches. We could have selected the entire object as well and done the same command. Note how some of the joints move in the horizontal direction, some in the vertical, some in both, and one point does not move at all due to the tolerance setting. In this next example, we wish to move the endpoint of the frame object onto a point with a column support. We select the endpoint and go to the Edit Align command and guess at a tolerance of 16 inches, which is not enough as the point only moves in the vertical direction. We undo this align and select the point again, but this time use a tolerance of 25 inches, which is adequate to move the point in both the horizontal and vertical directions. In this case, we wish to align the endpoints of two adjacent beams. We select the endpoint of the beam to move and go to the Align command. Here we enter a value of 23 inches, which we know is the approximate horizontal and vertical distance to the adjacent unselected point, and the two beams are connected. Now let's look at some of the problems that can occur when you use the Align command and lose track of the alignment hierarchy. In the previous example, we specified a tolerance of 23 inches, but let's say that we are not sure of the distance and input a larger arbitrary value. When we do this, the point aligns itself to the column supported point, even though an unselected point is closer, as column supports are checked prior to unselected points. Okay, we now know that 68 inches was too large a tolerance, and we have checked our model to figure out that a tolerance of 45 inches will exclude the column support, so that should align the point with the adjacent endpoint, correct? Well, no. In this case, it moved the point to a second unselected point, even though this point is farther away, because it was input into the model before the closer point, and the program checks in order of input. The safest way to control the alignment process is to add grid lines at the location where you want to move the point, because grid lines are highest in the move hierarchy. When we add grid lines to our adjacent point and use the Align command, we can be less accurate with the tolerance values. And in this case, specifying the previously used large value of 68 inches still results in the points being aligned correctly. In this last example, we will show why it is usually best to use the align command on a local basis. Here we wish to move the perimeter beams onto the grid lines. We select all of the beams and go to the align command. In the edit box, we specify a tolerance of 25 inches, which does indeed move all of the perimeter beams onto the grids. This time we will do the same exact procedure to move the perimeter beams onto the grid, but rather than use 25 inches, we will specify a tolerance of 50 inches, our thinking being that the interior beam is more than 50 inches away from the grids, so it will not be affected. However, in this case, the interior beam disappears. Its endpoints collapsed upon each other because the ends were closer than the 50-inch tolerance. In conclusion, the align command is very powerful, but has many nuances, so we suggest that you experiment with it on small models until you are familiar with its operation. This concludes this tutorial.